Hello everybody. Welcome back to another session on Python programming. We're discussing a very important concept of functions, wherein we have been exploring concept of generators yesterday. Now we are finished with the discussion of generators. I gave a lot of demonstrations to explain how generators work. Let's just go through the last part in the discussion that we had was about the method called as send, if you remember. So what was that send doing? That send method was giving you an opportunity to send some data to that generator, to the yield statement. So based on that, let's explore some more terms that you will come across when you're learning Python called as coroutines and subroutines. A basic demonstration we had yesterday, but with this context, I'll again explain what these particular terms mean. So as a Python programmer, you have to be very clear about your understanding of these terms. So now we are exploring a term called as coroutines and subroutines. So let's explore what it is all about. Coroutines, or it is called as subroutines. So what exactly are coroutines or subroutines? When we call normal function, we saw the behavior, what happens. Every time we call a normal function, control goes to the beginning of the function and goes on executing all the statements till we do not come across a return statement, or an exception is raised, or we have reached to the end of the function. So when we reach to the end of the function, there is an implicit return statement that is there. That's the behavior of a normal function. So every time you call a normal function, control goes to the beginning, goes on executing all the instructions inside the function till where? Till the time it doesn't come across return statement, or it doesn't raise an exception, or it reaches to the end of that particular function. If it's end of the function and you have not written return statement, you have not mentioned the return statement, it's an implicit return. Automatically the function will return. So there is an implicit return, but that implicit return returns null. So when you don't say return in the function, that function will return you none. So that's what it means. Then what are coroutines? Generators are also become coroutines, a more generalized form of subroutine. So coroutines are generalized form of subroutine. But then what exactly is a coroutine? If it's generalized form of subroutine, the regular functions are called as subroutines. And generators are kind of function. They're more generalized form of subroutine. So if somebody uses the term subroutine, understand we are talking about a normal Python function. And coroutine is a specialized form of subroutine, or a more generalized form of a subroutine. So the term subroutine and functions are exactly the same. Subroutines and functions are exactly the same. But now we are trying to explore what is coroutine. A lot of time people get confused. They say, we know functions in Python, but we do not know subroutines. Subroutines and coroutines are subroutines and functions is exactly the same. So you shouldn't get confused when you come across those terms. Interviewer a lot of times ask such kind of question just to confuse you and nothing more. And what's the behavior of function? Every time you call a function, control goes to the beginning of the function. It executes all instructions inside the function. And till the time it doesn't encounter return statement, or an exception is not raised, or it has not reached to the end of the function where there's an implicit return that will transfer the control back to the caller. But then let's explore what is coroutines now. Okay. Subroutines are entered at one point and exited at another point. So they enter at the top of the function and return where the return statement is encountered. That's the behavior of subroutine. Every time you call a function, it will go to the top of the function, go on executing the instructions till the time you do not come across the return statement. It can be implicit return or explicit return. But coroutines can be entered and exited and resumed at different points. So it is not necessarily like function. Whenever we call, it has to go to the beginning of that particular function. That's not the case. Coroutines are specialized or a generalized form of functions wherein you have an opportunity to enter into the function at different places and return from the function at different places. So entered and exited and resumed at many different points, and that's by using the yield statement. So while subroutines are regular functions, coroutines are your generators. Okay, so you shouldn't get confused. Subroutines are regular functions and coroutines are our generators. These subroutines, coroutines give you an opportunity to enter into the function at different places and exit from the function at different places. And that's where the yield statement has been returned. Now, when we are going to enter the function at different places, we have this send method that we saw yesterday. Generators can not only send object, but can also receive object. Normally, when we say yield x, or yield 10, it will return you value 10. But then if I send the value, the yield can also receive that particular value. Sending a message that is an object into a generator can be achieved by applying send method to the generator object. And that's exactly the demonstration that I gave you yesterday. We can, on the generator, we can call send method. So the data that we're sending, an object that we're sending, can be sent to the function at the point where the last place where you have yielded the result. Divided by the fact that both that the send sends a value to the generator and also returns a value yielded by the generator. So this is special. So when I send a value to a generator, it will take that value, but it will also return a value after you have given a call to the send. So send is special because it sends the value to the generator and also acts as a mechanism from where it will return the value from the generator. Both the things happen where the send method is called. We have one more method, close, that we did not saw yesterday. What is this close? It allows you to stop the generator. That means if I have an infinite generator and I want to stop it, I can just say close. Then it will not generate any more values. So if I have to control the infinite sequence generator, like what we saw yesterday, you can always use close method. It will raise stop iteration and exception used to signal the end of the finite iterator. So let's just quickly look at the send and the close method once again. Here we go. Let's have a look at this example. I have a simple generator wherein I have a counter called as whose value is 1. I have an infinite loop. I'm going to yield the value of the counter. Counter value for the first time is 1, so it's going to return you 1. Or it's going to act where the same value, whatever you send, that will also be received over here. So the data sent is data will print and counter is equal to counter plus 1. So counter will always keep on incrementing, and every time the incremented value of the counter will be returned to your caller. So if this function is already there in the memory, let's select it. Assume this function is already there in the memory. Assume this function is already there in the memory. I get the generator object G. We're calling a function which has a yield statement, makes it a generator. So I got the generator object G. So if I print what is G, you will realize G is nothing but a generator object. When I say next of G, what will happen? It will go to the place where the first yield value is there. When you say next, it goes on executing till the time you do not come across the first yield. And whatever is the value over here, that will be yielded and that will be returned over here. So at this particular line number 16, when I execute this particular code, I get the first value 1. If you notice, there is the first value 1 that has now been returned. But then next is not the only way you get into a generator and yield a value. Send also does the same thing. This time around, what I'm doing is I'm sending high. Mark my word, I'm sending high. So whatever value will get sent to the place from where the last yield has occurred. The last yield was from line number 11. Here say we have returned value of counter that is 1. So at this place, value high will be sent. That will be storing this data, and data sent will be high. Counter will be now become 1. 1 will become 2. And again, go back to the yield statement and 2 will be returned. So send does both the thing. It will send high and get the value 2. So let's check whether that really happens. If I run this particular code, look at this, data sent is high and the value that it has returned is 2. So both the things have happened. You could send the data, you could get the data. So here I could have just said data, or I could write this statement outside and just print the data, or I could take your string literal. I could just say g dot send high. Let's execute the code from here once again. Or let's execute the code directly. We are at this line. We get the generator object. We print that generator object. Okay, now when I said next, it went to the first line. Next, we'll take it to the first line. Counter becomes 1. In infinite loop, we enter. It has yielded the value of counter, that is 1. Note, you have 1 value aa chuka hai. Next, what I do is, after we have done that, I give a call to this particular function called a g.send. I'm going to send hi. Whatever value I send will get substituted over here. That will get assigned to this data, because yield does both the thing. It returns the value of the counter. It also receives the value that you have sent. So that sent value will now get assigned to the data. So data sent will be high, counter becomes 2, will come here, value of counter will again return. So when I'm line number 17 pe hai hum log, and if I execute that line 17, it says data sent is high and data received in the caller is 2. So I have sent high was received and assigned to this data. So it says data sent is high, and what it has returned is value 2. That means by the time you have come here, value of counter is 2. I do the same thing again. Next time I send by, I'm at line number 18 now, and I'm sending data by. So if I send by will get assigned to this variable data. It'll print data sent is by, counter become 3, and return yield 3. Let's see. We're at line number 18 now. And if I execute that particular statement, data sent is by, and data received in the caller is 3. Perfect. Now, if I am at line number 19, I'm going to send AA. The data that I send will now be assigned to this variable data over here. Data sent will be A, counter becomes 4, and then again we'll come to yield, where counter ka value 4 is being returned. So here, that's how it is working. So these are coroutines. Why? Because you have a chance to enter into the function at different places and return from different places. So I'm entering into the function at different places. First call to the next, we enter into the function at the first line. The next call to the next, we'll continue the code from this line. Okay, from the line from where you have returned for the first time. Yield not just returns the value, it also receives the value. Now for yield to receive a value, that means to a generator, if I have to pass some data while it is generating over a period, so in that case, I can call method send, and it can send different values to the generator for it to process. So that is about coroutines. So coroutines are subroutines wherein you have this kind of yield statement inside it. That means you have a chance to enter into the function and exit from the function at different places. You can enter at one place and exit at different place. So when for the first time it entered over here, and for all subsequent times it's entering over here. And later for you to return, you haven't done anything to return. It's an infinite loop. It will just keep on sending values and getting values every time you give a call to the send method. So that was more about generators that we have just now discussed. But we also saw there is a method called as close. Let's try and understand the behavior of this method called as close. I have this method called as greet, which receives the name. I could do some annotation saying, okay, name is type string, and this also returns a string. I have done some bit of annotation. So I have a greet function. Okay, let's not focus on the other functions. Let's talk only about greet function. So when I'm in this particular greet function, okay, it's an infinite loop. I say whatever message you send will now be assigned to this greet message. I am going to return that particular message saying yield message plus name. Okay, so let's do it. I give a call to this particular generator function. Oh, let's execute this and keep it in the memory first. It's there in the memory. I'm at line number 20 now. I say greet Akash. The moment I say that, Akash will be assigned to this name. Infinite loop hai. Name ka value Akash hi rahega for its lifetime. But when we come here, yield, you are not yielding anything. Okay. So if I just say next, here next of G, it will take me to this yield. It's not going to return anything. It's going to return none. But here later, next call will take over here and it will return you greeting plus name. So greeting जो भी रहेगा आपका yield का जो value return किया गया है वो value and plus the name of the person whom they have passed. So let's see. We have this greeting Akash over here. We have greeting Akash. And then I say for message in bad word list. Okay. I have a bad word list and I have a good word list. ऐसे दो list है मेरे पास. One is a bad word list and a good word list. एक है bad words are A, B, 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 C, C, C. Good words are good morning, good evening, good afternoon. C, 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 C हटा देता हूँ मैं. Suppose good night, These are some good words that we have. Assume. So we have two lists, bad word list and good word list. I just execute the code once again. I have two lists. And then what do I say for message in bad word list? Oh, bad word list में एक दो तीन messages है. I call the next method G. Now when I call the next method G, I'll come over here and I'll stop. I say result with G dot send message. अब message में क्या है? Bad word में से पहला bad message A. So that A will be sent over here. So that will now get assigned to greeting. I'll say what is the A name? A name. I could take some list of bad words. Okay, instead of taking bad words, I'll call it slang words. And we'll take some of these slang words which are there. I'll just change the statement saying it's a slang word. ओम जी है और बाकी क्या थे पीबीएच क्या है टू बी ऑनेस्ट पीबीएच
YOLO game.
So these are few slangs that we used. I'm going to use this slang word list over here now. Okay. So when we start with this, I say next G, it'll take you over here, it'll stop. It'll return nothing, none. Because after yield, I have not written anything. So it will return none. Then I say result is equal to G dot send message. So when I send the message, I'll get OMG. OMG will now be assigned to this message. So it'll say yield OMG space name. That will be stored here and it will get printed. In the next pass, after this, when user calls next method or when we are in the for loop, we saw yesterday when Viraj had asked a question, for loop implicitly call next method. So you don't really have to worry. So we'll go to the next one. So it will go here, yield nothing. So this next will yield nothing. We are here, it will yield nothing. It is just a list. And if I want to avoid this, that could have also been done. Let me see if I've done that. No. So I'll write this particular code again in a different way so that I'll avoid call to this next method. Every time I'll send this data. So next time it will again yield nothing. On line number 26, it will yield nothing because yield is returning none over here. Then I say result is equal to G dot send message. So the value of message over here right now is Akash again. So we'll go over here. Send message. Message may it will be TBH. So we'll say TBH plus name. What was TBH? To be truthful. To be honest. So it will be to be honest, Akash. ऐसा कुछ तो करेगा. So let's run this particular code and see what happens. OMG Akash, TBH Akash, Drew Akash. Okay. Let me write this code because that comes to my mind in a different way to get the same work done. Oh, I had to send the different messages, so there is no way we can do it. Had there be only a generator through which I have to run, I could have done that. Oh, this is the only very good way. Now I have some good word list. Same thing now. Good morning, good evening, good afternoon, good night. ये चार अच्छे words हैं. So when I say message in good word list, I'll first get good morning. So here, when I say next, it'll take my control over here. It will stop. It'll yield nothing. So here, if I print this value, it will give none. It'll yield nothing. But it'll stop over here. So when I say send, the control will go here, and whatever good morning you have assigned, that will get assigned to this great message. So it's a good morning, Akash. So next time it will be good evening, good afternoon, good night, Akash, Akash every time. So let's run this particular piece of code and see, do we get the same result? Yeah, good morning, Akash, good evening, Akash, good afternoon, Akash, good night, Akash. All those things are happening. Just to understand the difference between send and the regular methods, here I go. I say if message in bad word list slang word list. Let's take some more word from the slang word list. What is this? Laughing my ass off. Okay. Let me see the real life. Let me LMRIL. Okay, that's some slang word. And suppose somewhere over here we have that slang word. Or here we have that slang word. We have that slang word. So we have slang word list and we have good word list. Suppose. Now here when we went through this, it'll use all the slangs. Here we went through this, it'll use all the good words. But one word over here was slang. LMIRL Akash, what it is. So I say for message in good word list, and if message in slang word list, that means the message in the good word list, if it is present in the slang, then I'll close. I'm saying close and break. Break will take the control out of the loop. So we're trying to understand this close. Close will stop the iteration. So for the first time, we have a method called as word called as good morning. That's the message in the good word list. Is it present in slang word list? Is good morning present in slang word list? Condition is false. So false है तो आप close या break नहीं करोगे. You'll go here, say next. So next will take you over here and stop. So whatever is the message that you send, that will get printed. So good morning Akash or whatever is printed. And then it will go again over here and it will check message in good word list. Okay, whatever is the message, it will get the next message. Next message is good evening. And the good evening is in slang word list, false. So we'll go to the next. The next will take it again over here. It will stop. Same message I send and will print. So I send that good morning message over here. It will say good morning Akash and it will go to the next pass. So यहाँ जाकर रुक जाएगा. Message in good word list. So next message in good word list is suppose this one. Suppose that's the next message. We got it. And we check, is that message present in the slang word list? Yes, it is present. So I'll just say close and break. So close will stop the generator to generate any value. So a good afternoon, good night वगैरह कुछ नहीं आएगा. So let's see this execution. We run this particular code and what we got is only good morning Akash and good evening Akash. Because after good evening we had this particular one. Let's see the behavior also how it is working over here. I will debug the code till here. We are in over here and we get the words. The message over here right now is good morning. I say g.next. They'll start. It'll yield this particular function. Okay. It'll continue from the place where we stopped last. So for that purpose, what will I do is I'll comment out these statements over here. These two loops. Because we can iterate over it only once. So I'll just comment out these statements. Or instead of commenting out these statements, I could reconstruct the generator object. All this time it was Akash. Next time I can take somebody else. I'll say over here Ashish. Okay. So I'll reconstruct the generator object. Here I am. I'm here. So I say greet Ashish. In that case, Ashish is sent to this particular method. Okay, but not that. It will actually create only a generator object. So G is your generator object that has now been created. I say for message in good word list, I get the first message, that is good morning. Is message good morning present in slang word list? False. So when I say next, control goes over here. It'll go on executing the statements and it'll stop over here. It'll yield none over here. From here it yields none. And then we say g dot send message. Current message is good morning. So good morning will now be sent. Where? From where we return. We yielded from here. So there the good morning will be sent. Watch it. Good morning is sent to that line. Now greet message will now receive that particular value. So we yet do not have this method variable called as greet message. But we'll get one. Watch it. So we have this greet message that got value as good morning. And then we are going to say good morning, Ashish. After we have sent that, it goes here and again it yields none. Okay. And again it prints the next message. Generator exit. Okay, what has happened? Let me trace this particular code once again for you. Here we go. We got the generator. I have to run from this particular statement. We are here. The generator object has been created. G is the generator object. And we say for message in good word list, we get the first message in the good word list, that's good morning. And I say next, that will stop at yield, it will return none. When I say send and I send this good morning message, that good morning message will now be sent to the generator over here. That will get assigned to this variable called as greet message. And then we're going to greet Ashish saying, good morning, Ashish. Watch it. That value is returned and we print. So when you print that message, it says, good morning, Ashish. I get the next word, that's good evening. So suppose we get the next message, that's good evening. Again, we say next. Okay. So it goes to the next yield and stops. When I say send, so in that case, we're going to send this message called as good evening. That will get assigned to this variable. That will say good evening, Ashish now. That has been returned and that has been printed. Good evening, Ashish. After that, again we check, is that word UMIRL? Okay, is that present in the slang? Yes, it is present in the slang word list. So I'll say g dot close. The moment I say g dot close, the iteration will stop. Okay, and we'll break from that loop. We come out, and if I say next, it's a stop iteration because it will assume like it has exhausted. Generator has exhausted. So close, call to this close will stop the generator from generating the values again. The moment you say next, it's gone. Okay, why? Because close has terminated the generator. So if I call this g.close, generator.close, it will stop generating the values, which may be there inside the generator. It will stop. It was an infinite loop that we had. But now, the moment you said close, the generator has stopped yielding the values. Just to understand this behavior, let's have a look at this one more example. For I ka value 0, we have an infinite loop where while is true. We are incrementing the value of I and we are constantly yielding, we are generating the squares of the numbers. First is 1 square, then 2 square, then 3 square, 4 square. We are generating one value after another. Note, it's an infinite generator that we have. Infinite generator. So I'm calling it a generator sequence square infinite. That's the name that I've given to the generator. Now, suppose we are at this line. Let's stop executing. Let's comment out these statements that we have. Let's comment out the statements that we have. And let's jump over here. I say generator square infinite. I say next. Moment I say close, it will stop. Otherwise, as many number of times I say next, that many number of values will get generated. That many number of squares will get generated. Let's have a look over here. We are here. And I say next. I'll get the first square, 1 square, then 2 square, then 3 square. So 1 square is 1, 2 square is 2, 4, 3 square is 9. I say g.close, it will stop generating the values. So it's like termination of the generator. And when I say next after that, it will say stop iteration because you have terminated the generator. So if I have to stop that infinite generator from generating the values, there is nothing that we can do inside the generator. But on the generator object called close method, it evokes stop iteration. If after closing the generator, if you try and fetch the value from the generator, it will always raise stop iteration error. So the error called a stop iteration has been raised. Why? Because you're asking the generator which has been closed to give you a value. So once a generator has been closed, it no longer can yield any more values. So that's the difference between a regular subroutine and a coroutine. Any questions over here?
Sir, is close similar to
Any
pop?
questions so far? Which feedback?
Sir,
Yes, please.
sir, is close method similar to pop?
No, no, no. Pop was the one that popped out the value from the container. Close is not popping out or getting you some value. It is just stop. It will stop that generator from working further. That means if I have infinite generator and if I close it, that means henceforth you cannot call next method. Neither can you call the send method. That means you cannot anymore use the generator after calling close. Close means that generator object is over. It's like uh, discontinuing the use of the generator. So if you do
Like we
not want the
break in the while loop.
pardon?
Like we break it in the while loop. Like we want
The
to
while
break
loop,
it out
when you break
from
the
the.
while loop, it will terminate the while loop. So
Yes.
likewise, you could that's a good analogy to draw. We break a while loop, so that loop gets terminated. It will no longer function. So likewise, if I have a generator and I have to terminate the generator, you could just say close. But to terminate a loop, we wrote break inside the loop. Here, the generator object was generating the values for you. So you have to call close on the generator object so that it no longer generates whatever it was supposed to generate. It is termination of that generator object.
So, sir, what will be the impact if we don't close it?
Impact will be like as long as your application is running, that generator object will be present in the memory.
So it will be just consuming the memories.
Yeah, yeah. So and
Uh,
in case by mistake, if you call the next method or the send method, it will give the next value for you.
okay.
So if you want to say that, oh no, don't yield or don't give me any more values to the generator, then call close on that generator. So it's a way to tell the generator, stop now. I don't want any more values.
Okay.
But sir, can you call it again?
No, once closed. We could check what happens if I call it again. That's what we could do. So if I have closed the generator and I call the generator once again, that has been already closed. Okay, that is having no impact. It is neither generating any error. But once close is closed, but if I try and call next method, it generates an error. If I call send method, that will also generate an error. Let's see. If I say g dot send, if I'm going to send some value, suppose some value, and I'm here, and if I say g dot send once again, it will again generate stop iteration because you already closed it. So once you close, neither can you call next, neither can you call send on that particular generator. It's over. The generator object is no longer working. Object is there in the memory, but that object is no longer doing what it was doing earlier. Point is, you have stopped generating the values from the generator. I'll say the generator has stopped yielding the values. So your generator was always yield. It was giving you something, yield. Yeah, it was it gave you an opportunity to yield some data, get some data. That is stopped.
So in the same code, we can stop it, and also we can we again initiate it?
No. If you want to reinitiate, you'll have to create one more generator object.
Okay.
But the same previous generator object will not come into action.
Okay.
It will be a new generator object that is there.
So can we write that f equals to and call that instead of g?
Tell me what you're saying.
So on line 47, we have written g equals to generator square info. So we are calling that generator.
Calling
So
name. Yeah, okay.
I mean
When we call a
initiating the
generator
generator.
function, what we get is a generator object.
So can we write f equals to generator square?
Yeah. You can have multiple generators.
So it will again initiate, right?
No, these are two different generators. F has nothing to do with G. You have closed G, that does not mean F has got closed. F is still working.
Okay.
Okay. So just to see this, first were working. All of them 149 I got. I said G dot close. So G has got closed. I said G dot close. So G has got closed. If I say next on that G, it will generate an error. Stop iteration. If I try and send something, it will generate error. But if I call, let me not say F over here, that will create a confusion. Let's say suppose X. But now if I say F dot print next of F, you'll get the 1 ka square. You have close G, not F. 1 ka square, then 2 ka square, then 3 square, then 4 square, then 5 square, then 36 square, 49 square, 64 square. But if I now close F, if I say, and then if I try and get the value, that will also generate an error. So if I go to line number 56, I close the generator F now. And if I try and say next, error.
So, sir, you have to just assign another variable for it.
No, you have to create one more generator object. So the function is always there in the memory. The function is there. So you can instantiate this generator object, I'll say. Actually, every call to a function is like instantiating a function. We get a better understanding about this over here. So if I call a generator function, it doesn't get called, or rather it returns a object. And that object is nothing but your generator object it returns. And I can call it any number of times. Every time I call, I'll get a new generator object. Any question? Okay. Have you received the files? I just sent the file with the change thing that Rahul was asking. Have you received the generator clause once again?
Yes, sir.
I shared 6 and both. Generator file I had shared with you yesterday itself. So that's all about generators. The only thing about generators that I have not touched upon right now is generator expressions. So we saw subroutines, coroutines, and we have understood what those concepts are all about. Now, having discussed this, let's jump ahead with the next topic for our discussion. That's rather far more simple topic that we can come across. So the next topic of discussion is based on one statement in Python. In Python, we say everything is object. Your class is an object is an object, file is an object, module is an object, package is an object. Everything in Python is object. Okay, so just keep that thing in mind. So even functions are objects. Even in the visualizer, when we declare the function, it used to say function object created. Here we got generator object created. So in Python, everything is object. Okay, and that's how Python has been designed right from beginning. Now, what is that we're going to discuss then if everything is object? Okay, so now we'll talk about functions as object. And how do we make functions behave like object? Okay, we can actually do a reverse way also. We can make object behave like function, but that we'll just touch upon. But that's not the topic for our discussion right now, because we haven't yet seen classes where we can create an object of user-defined type. So today we're going to look at functions as objects. Functions are first-class objects in Python. Now, if anybody uses the word first class, that means it's not second class, third class. But then this is a very important statement that we make over here. I should have highlighted actually over here. So let me just highlight that statement because it's an important term that is used in multiple languages. Okay. I have highlighted it again. We'll see the presentation. But there is a lot of significance behind this term. So when I say functions are first-class objects in Python, meaning they have attribute and they can be referenced and assigned to a variable. to put in other words. If I have a variable, say you're working in C language or you're working in C++ language, you say int I. So moment you say int I, you have created a variable of type integer. Now listen to me, you may write later. If I have variable is what I have created. What can I do with the variable? I can assign value to that variable. I can pass that variable to a function. I can return the value of the variable from the function. So anything that can be treated like a variable is like a first-class citizen. For anything to be called as a first-class citizen, we should in position to assign it to some other variable. So I can say, suppose I int I can say int b is equal to I. That means value of I will get assigned to b. So in Python, functions are also first-class citizen. Means what can we do? We can assign them to a variable. So I can store a function into a variable. Well, listen, believe what I'm saying. I can assign a function to a variable. I can pass a function to another function. I can return a function from a function. So we say functions are first-class citizens in Python. So first-class objects because we can assign them to other variable. We can return it from a function. We can pass it to a function. That means all the things that you can do on your normal variables, you could do on functions as well. Functions, Python also supports higher order functions. So two very important statements we are looking at today. First is first class object. Second is higher order function. Now, what is a higher order function? That will take us to the next topic, or probably the second last topic in functions in Python, called as nested functions. So Python supports higher order function. Means you can write a function which accepts another function as an argument and returns a function. So I can have a function whose parameters or arguments that I pass to that particular function is another function. Till now, what have we done? To a function, we have been passing data as an argument. If I have to add two integers, I pass 5 plus 4, add 5, 4. So how about passing a function as a parameter to the function? So if that is possible, here it's a higher order function because functions can be treated like a normal variable. You can pass a function to a function as an argument, and you can have a function that will return the function from within itself. Function or objects may be assigned to another names, embedded in data structures, and more as if they were simple numbers or string. So the way you handle your basic integers and strings, you could also do similar operation on your function objects. What are things we can do? We can assign it to the normal variable. You can pass it to a function, and you can return from a function. All such operations we can do with functions in Python because functions in Python are first class object. Functions in Python are higher order function. So these are very important terms that we have to understand. They are higher order functions. So let's jump on to the further discussion. Okay, Python functions are first class. Why? You can assign them to variables, store them in data structure. I forgot about this. Store them into data. So that means I can have list of functions. I can have a dictionary of functions. I can have set of functions. I can store them into data structures, pass them as an argument to another function, and even return them as a value from other function. Please note this. In any language, if you see something is called as first class citizen or first class object, we should in position to carry out these 4 operations on it. If you can carry out these 4 operations, they are first class. Either take a note or take a snap. But that's very important. If somebody asks you about special things about functions in Python, you could just say they are first class citizens or they're first class object. Why? Because of all these things. Yeah. Okay. So let's not go into indirect function call. Let's look at this functions as object first. I'm looking at a function name. Where is this function an object? Watch it. I have a message called a function called as show. You have a message as a parameter, which is of type string. What is the message? We're going to capitalize that particular message. So what's so special over here? So before I do that, I need to understand the statement called as indirect call. Let me come over here first. Let's look at what is indirect function call. Okay. There's nothing special about the name used in def statement. So when I say def foo, nothing special. In that case, foo is just a variable assigned to in the current scope as if it had been appeared on the left side of equal to. That means it's as good as saying function object has been created and it is assigned to a variable called as foo. So when I say def foo, def send def greet, so that greet, foo, function names that we give are nothing but like variables which are referring to the function object. You must have seen this when you had visualized the function. If not, let's look at the visualizer that actually demonstrated what's happening. If I come to this Python visualizer once again, if I come to this Python visualizer, some Python visualizer we could open. And if I say def some function foo or some function called as do it, I hope it is visible what I'm typing. Yes, is it visible?
Yes. Yes, sir.
If name equal to main, I'm going to call method called as do it. Watch it. So when we visualize this function, see what happens. The first thing that happens when I define this function, see what's going to happen in the memory. So do it is just a name that refers to this function object which is kept somewhere in the memory. So it's as good as saying x is equal to 10. So if I say x is equal to 10, 10 is stored somewhere in the memory whose address is stored in x. So in that case, do it is just a name that's a variable. It's like a variable, or it's the name of a variable or identifier which is referring to the location in the memory where that function has been stored. So this function is nothing but an object. So function object has been stored somewhere in the memory, and do it is only referring to that particular function in the memory. It's just like a reference, just like a variable. So when I say do it, when I define this by using this statement, it is as well as saying do it is equal to this function object. That's how it is. After the def reruns, the function name is simply a reference to an object. Look at this function name is simply a reference to an object. It's a referring to an object. It's simply a reference to an object. You can reassign that object to another name freely and call it through any other reference. So if I have to call this function do it, I don't have to give the name do it. I can say did it, and same function can get called. How? And that's what I'm going to demonstrate. Okay. And then there's also something called storing a function. You can store a function into any data structure, list, tag, list, and the map. Sorry, what are things we have seen? Map is in Java. Here we had a dictionary or a tuple or a set. You could store them anywhere. So I could have a list of functions and I could just call those functions one after another. You could pass a function to another function. You could have a function as an object, and you can treat an object like a function as well. Okay, for this, let me give all the demonstrations now. Here we go. So I have this simple message called as show. I have this simple message called as show that's ready in the memory. I have to give a call to this function. So I say show. So definitely control will come over here. It will execute this particular message saying show in capitalized. So I've already said direct call. So it capitalize karega, and D or C capital hoga, everything is small. Everything else is small. I run this code. Okay, it says direct call. It has printed. Great. Now I say show display is equal to show. It is as well as saying x is equal to y. That means display will now be, suppose if I write that kind of statement over here, if I say did it is equal to do it, suppose, and then I call did it once again. And here instead of saying pass, I'm going to say print. Inside the function. ऐसा कुछ लिखा है. Let's visualize it. There's an implicit return statement that is there. Here we go. So do it is just like a reference, referring to this function object somewhere in the memory. When I call this do it, we come here, frame is loaded. We go here, we print the result, and then we return none. Implicit return. अरे आपको वैसे return नहीं लिखा है. That's implicit return. Yeah, return क्या नाम? I now say did you equal do it. This is important now. This is what I'm trying to say. So while do it was just like a reference, referring to a function object. So did it is one more reference. Both these references are referring to the same object in the memory. So if I now give a call did it, did it just a reference to this function called as do it. Did it is just a reference. Watch it, visualize. It's just a reference referring to the function object called as do it. So same function will get called because it is just a reference, and then it returns. So now you have two references referring to the same function object in the memory. So I can assign a function to another reference, another variable. So your function name is also like a variable, also like a reference, which is referring to a function object. And if I have assigned that reference to another variable, that becomes another reference to the same object. Okay, as we are saying, s is equal to string, some string, hello, and then s1 is equal to s. So s1, s1, both are pointing to the same string object. So that's, let's see if that is how it will demonstrate over here. If I say s is equal to hi, that's the string. And if I say s1 is equal to hi, and I say s2 is equal to s1, and I say print s1 comma s2, something I had to say. You watch it very carefully. What's happening? We give a call, do it. Okay. After that, we return. Now I say did equal do it. So did it and do it are both references to the same object. So it goes inside, it will print the result. We come out. I say s1 is equal to hi. I say s2 is equal to hi. It's not demonstrating correctly. So this is not how it is stored. If say demonstrate nahi kar raha hai. Okay. How it should be the case? The case should be like s1 is referring to hi. s2 is also referring to hi. Both are references referring to the same object. So not always this visualizers visualize it correctly. It treated it like just a regular variables in any other language. But anyway, so here when I say display is equal to show, I'm creating one more reference called as display that's referring to the same function object to which show is referring. So display and show both will refer to the same function object now. Here I go. And then if I say display indirect call, I don't have a function called as display. How am I calling this function display? Because display is one more reference referring to the same function show. So if I run it, it says indirect call. How did that happen? I pass this indirect call in uppercase. It has got capitalized and then it has printed I capital like a sentence. I say del show. If I can create a variable, I can destroy that variable. So if I now make a direct call, the program will crash because there is nothing as show in the memory now. Show has been destroyed. So we are at line number 28 now. And here if I say show, it will say, oh, the name show is not defined. And you want to see a proof of it, just say dir over here. In dir, you had this slang word list, you have simple word list. You'll also have display somewhere. Display here. But there is no show. That has been destroyed. Let's recreate a new this thing so that you don't have too many things. So I had defined this function show. I call this, I call this direct call. We got the result. I assign the function to another variable, function reference to another variable, display. I give an indirect call. Okay, that will also do the same thing, indirect call. But later if I say del show, and then if I say show direct call, that will raise an error. It will say, I don't know what is show. Variable has been displayed, but it knows what is display. Because display is still referring to the same function object. Indirect second time. If I want to know what's the name of the function display. So display is not the name of the function, it's just a reference referring to this function called as show. So if I look at this attribute called as name, surprise, surprise, it says show. But if I say show.name, it will generate error saying, oh, there is nothing as show that we have. We don't have anything as show here now. Here you go. If I say show.name, it says, oh, I don't have anything as show. There is nothing as show. Now, if I say display.doc, Oh, you'll get the simple function to echo the contents passed. Watch it. Simple. That's the documentation string. That's another, and that's another uh, attribute of a function. I say display, print display. It says it's a function show stored at this address. मैं कह रहा print display. So display is actually reference to this function object जिसका नाम show था, original name show था. I say display dot name echo message. उसका नाम change कर देते हैं. Display dot name is echo message. So the name of the function was show. Now I'm saying echo message. So last time when I said display dot name, it gave us answer as show. Now I change the name. Display dot name is echo message. And now if I say display dot name, it's no longer saying echo. It's saying, yeah, it's no longer saying show. It's saying echo message. And then if I say show is good display, and I say show dot name, it still says echo message now. Why echo message? Because that's the name that you are given to that particular function. Now if I say show new message, that's perfectly all right. It says new message and so on. The point over here is we can assign a function to another variable. Actually, neither of these are functions. Show is a reference to a function. Display now becomes a reference to that same function. So you can assign one function reference to another reference. So that's one part of why we call functions as objects in Python or first class object, because they can be assigned. Any questions till now?
Sir, we can create those references for
Louder.
generators also, no?
Come again.
Sir, can we create those references for generators also?
Yeah, generators are functions.
So, sir, it is possible, no?
Yeah, generators are subroutines, special subroutines. The only difference is generators are subroutines where, unlike function, in function you can enter only at one point and exit at return. Generator you can enter and return at different places, coroutines. So generators are coroutines and coroutines are subroutines. Subroutines are regular functions. So all these things that we're discussing is also available for coroutines. Just sharing this file with you. Have you received the function object?
Yes, sir.
Now that was a very simple example that we looked at. Let's do something more. So, because what are first class objects? We should be in position to assign them to another variables, references. We should be in position to pass it as an argument to a function. We should be in position to store them in a data structure. We should be in a position to return them from a function. These are 4 things that we should be in a position to do for them to be called as first class citizens or first class objects. So let's look at the second one. I have a function called as multiply, and it multiplies n1 and n2. I have a function called as plus, addition, add. That will add n1 plus n2. I have a function called as divide. That will divide first with second. Let's do integer division. We'll divide first with second. I have a function called as power. It will give first variable raised to second variable. So I have all such functions which are there. There are all such functions which are there. Okay, very simple functions. Now what do I do now? I create a set of functions. I say user defined function set, add, multiply, divide, power. And note curly braces. It's a set. So I have a set of functions that I have defined now. I have, and that is a set of user defined functions. These are my user defined functions. Then I have predefined functions called list, string dot lower, string dot capitalize, string dot upper. So I have now a list of functions. एक था set of functions. Now I have a list of functions. Okay, we are at line number 32, and what we have is a list of functions. And then I can also have a tuple of functions. But these are all predefined. Length, sum, max, min. These are all predefined functions. So we have three different data structures. One is a set, other is a list, other is a tuple. So I have a set of user-defined functions. I have a list of predefined methods or functions. I have a tuple of global functions. Correct? Let's do it. Now I say for func in predefined function list, print func. So I'm interested in printing. What would happen if I say this variable add? If I just print add, if I say print add, it says okay, it's a function in the main whose name is add and which has these two parameters. Okay, that's what we get. So what I'm going to do now in this loop, I say for function in predefined method list, add, multiply, divide, power. I'm printing that function name. So I should get information about those functions. It says in list का क्या? Okay, list is this. List में क्या क्या है predefined function में? Lower, capitalize, upper. तो method lower of string object, method capitalize of string object, method upper of string object. So it has identified. So I'm cycling through this list of methods. Lower, capitalize, and upper. Okay, I got the information about these things. It says there's a method called as lower, capitalize, and upper. Okay, आगे देखते हैं. I say for function in predefined function tuple. अरे length, max, min ये था. So if I want to run this particular function, ये आ गया. Built-in function length, sum, max, min, and so on. I could do something more. I could also get that description. Now to get that description, what I have to do at most? क्या हुआ यहाँ? Slash and name function. Here we go. I say function dot doc. तो moment I say doc, tuple में length, max, min है ना? इनका documentation आ जाएगा. Okay, this built-in function length के बारे में जानकारी, sum के बारे में जानकारी, and then max के बारे में जानकारी, then information min, and so on. All the four functions information has got printed because it said function dot doc. Okay, so it is giving you documentation of that particular function. This is the documentation for tuple, na? Min function. This is a documentation for that's for min. Oh, since I have a tuple, okay. First is documentation for I got it for max. It's not ordered, na? I'm getting documentation for all these predefined functions. Length, sum, max. So I'm getting an order. Length, sum, max. तो कहा गया length, sum, max और एक min चाहिए. Max function है, ये min है. So this was information about max. This is information about min. So we are getting those things. Suppose user-defined function का set था add, multiply, divide, power. What I can do now, I'm saying for func at id func. So I want to know what address that function object has been stored. So this multiply function is stored at this address. Divide function is stored at this address. That's id. These are function IDs. So I say id of func. Get me id in decimal format. This is probably also an ID of that particular function. Okay, unique identifier for that function. But I'm going to do more. What more? Okay, after doing this, here we go. This was all special, simple. I just focus on this. For function in predefined method list. Predefined method list में क्या है? Lower, capitalize और upper, ये तीन है. Okay. So what am I saying? For function in predefined method list, okay, I say function dot name. Function dot name है तो min max जो रहेगा. That's the attribute of function. And here I give a call to the function with saying, hey there, look at the way I've written Y capital, HE capital, rest all small. Weird format. Huh? But what will happen for the first time is in predefined method list, पहला function है lower, दूसरा है capitalize, तीसरा है upper. That means here it is as good as calling that particular function upper, lower, capitalize, all those things. Why? Because I say func in predefined function method list. Predefined method list में कौन कौन से function है? Lower, upper, capitalize. These are four methods which are there. It will run through those methods. Let's do that. Here, lower, hey there. capitalize here only H capital, and upper here everything capital, lower means size small. So what is happening? I'm calling different functions at different times over here. So when I say for function in predefined function list, the first method over here was lower, because as we are saying lower here there. Then it's saying capitalize here there. Then it's saying upper here there, and so on. Okay, but that was for the predefined method list. Let's do the same thing for our user-defined function set. Usage देखते हैं. I have two variables n1 n2, and I say for a function in user-defined function set, function dot name, that's max, min, multiply, addition, subtraction, जो भी आपकी multiply, add, divide, num, plus I have given documentation string to understand what that function is. Okay, user-defined function set. If n1 I want, and I'm trying to format it, I'm saying left alignment chahiye, two column width chahiye. That is what I'm saying. Then I have this function dot doc. I'm saying only in two column width, center aligned with 2 is what I'm trying to say. Ye left aligned, ye center aligned. Then I have n1, n2. n2 ka value 7 hai. That's also left aligned. And then I call that function n1, n2. So when I say for a function inside function, so when I say for a function inside user-defined function set, तो user-defined function set में पहला function कौन सा add है, फिर multiply है, फिर divide है, फिर power है, and so on. So here it is as good as calling that particular function. It is as good as calling that particular function. Okay, so let's do that. I'm going to call this function n1, n2 के साथ. It says 10 multiply 7 is 70, 10 divide 7 is 1, 10 add 7 is 17, 10 power 7 is 10 to the power 7. Now, how did it happen? Because they say n1 less than n2, n1 left aligned into width, ये दो column fit n1 के लिए 10, 10, 10 जो print हुआ है. Function dot name, oh that was multiply, divide, add. But that I have taken the center spot of 8 blocks. Total width is 8. And you must have figured by now why it is 8, because you have one word called as multiply, that's too long. So I have taken 8, center aligned है. And then I say n2, that's my 7 number. And that n2 is also left aligned. Kavya. N2 is also, okay, left aligned by 2. And then I give a call to this function n1, n2. So when I'm calling this function n1, n2, 10, 7 is what I'm giving a call. So first time multiply has got called. Okay, and n1 call is 10. 10 into 7 is 70. Then divide kya, 10 by 7 is 1 integer division. Or if I don't do integer, I'll get 10, 1 point something. 7 add 7 is 17, and 10 power 7 is 10 to the power 7, and so on. So you could have a set of functions, you can invoke those functions. So when I say for a function in user-defined function set or user-defined function list or a set, okay, wherever I want to access it, you could go ahead accessing it. So I'm saying for function is user-defined function set. Every time I get the function, I can find out what's the name of the function, actual name, and I can also invoke that function with an alias, an additional name that we have given. Have you all understood this? Function object 1. Let me share this file with you. You got the program?
Yes.
कुछ query तो अभी पूछ लो. So we saw function can be stored in data structure, and the data structure that we used to store was nothing but a list, a tuple, and a set.
सर अगर बिल्ट इन फंक्शन को असाइन कर दिया था,
बिल्ट इन फंक्शन का क्या?
को असाइन कर दिया कोई दूसरा फंक्शन.
हाँ. If it's a global function, it will create, no, it will not generate any error. Will not refer to the predefined function. It will now refer to your user-defined function. So that's a big risk that we have, especially when you use the word max, min, our program, we create that issue. Look at this. There is this function called as length. function length of, suppose if I say ABCD gives you 4. Perfect hai? Yes or no? But now I say def get max, suppose get max, and whatever string we pass of type string, this will return an integer. And I say return suppose max of str. So that's the function. So suppose if I give a call to this method called as get max, and I pass some data to this particular function, that is what I pass. Okay. So get max, it's a string max of str. Max of s के नाम हो गया. That was my example. Now if I give a call, Dadaji, let's say J is the maximum letter over there. DA, J, that G or whatever. J is the maximum. Or if I say get max of XYZ or YZX, it gives you Z. You may say, sir, क्या चल रहा है? क्या बता रहे हो? See what is going to happen. If I now say length is equal to get max, so earlier length of ABCD, we had already given this call. Length of ABCD give you 4. Up there ready. So now length no longer refers to the original length function. It is now referring to the get max. Is that okay? This is a big problem in Python. Why? Because mistakenly, if you give a name to a means if you have a function with some name and mistakenly you don't recollect that and you say that name, say length is equal to get max. So length is no longer any function. It's referring to this new function called as get max. Other languages, it could generate similar errors, but in Python, it says, okay, just identify. Yeah, it doesn't mind what name you give it to it. So even for predefined function, name can also be lost or overwritten, you can say, or yeah. And I could del also. I could delete that thing as well. There's more about del now that I should discuss. So now suppose if I'm saying length, and I'm passing x, y, z, instead of giving 3, it is giving me z. But now I say del length. So length is destroyed. Now if I say x, y, z, you get the original behavior. Have you understood this? Length was a name referring to this get max. When I say del length, so that length which is referring to the get max, that has been destroyed. Original length is there, which was suppressed. So now if I say length of x, y, z, I get 3 instead of getting z. Have you understood this?
What if I del get max?
Okay, then everything is gone because you do not have any more references to it. But before that, if I had said g is equal to get max, so if I say get max of this, it's giving me s, that's great. But if I say del get max is gone. So this statement will generate error now, but you are already assigned it to a variable called a g. If I say g of something 1, 2, 3, it says 3. But if I say del g as well, now there is no way you can get max or both the statements generate error. This will also generate error, and this will also generate error because you have destroyed all the names, all the references. The object is destroyed now. Understood this?
Sir,
Yes.
when object gets destroyed, you have to create it again.
Pardon?
When the object gets destroyed, you have to create it again.
Yeah, of course. Actually, object get destroyed in Python. You cannot destroy object. Listen, in Python, you are not destroying an object. You are destroying references to that object. When I say del get max, I did not destroy the function object. I destroyed the reference referring to that function object. But think about a scenario. आपके पास object reference नहीं है और object memory में भी है. If it's there in that memory, you still can't reach it because you don't have a name pointing to that. Your reference is lost. Since your reference is lost, irrespective of whether object is present in the memory or not there in the memory, you no longer can access it because you do not have the reference to the object now. Okay. Beyond that, when will Python collect it from as a garbage from memory? यानी memory में से उसको कब actually delete करेगा? We don't know. The function object may be there in the memory till the time it do not fall short of memory. There is something called as garbage collection in Python, and the implementation of garbage collection from one implementation of Python to another implementation can change. So we as a Python developer are not really bothered whether the object is still there in the memory or it is collected by Python. It will definitely be collected by Python at some point of time. Collected means the memory that is allocated for it will be released. That will happen sometimes, at some point of time, but we are not aware as to when will it happen. You have only deleted a reference to that function object. Object may be there in the memory, but you don't have a way to reach that. Why? Because reference is not yours. It's like if you're in a college, on the last day of the college, we take all our friends' names and everything, and you have noted down in a diary. Our time it used to be a diary in which we used to note the address and the telephone numbers. Those days we had landline numbers we used to note down. Suppose I create a diary in which I mention names of all my friends. I get their phone numbers, and one fine day, whenever I want to reach them, I open up my diary, take that phone number, and I call that fellow of mine and I reach them. But the day when the diary is lost, can I reach my friends now? Can I call my friends? No. Does that mean my friends have been destroyed? They're still alive and safe, but I don't have a way to reach them because I have lost the reference to that friends. So your names are just like a reference to that particular functions. If you lose the reference, you cannot any longer reach that function object in the memory. Have you all understood this? Let's now look at the next part. The next part is about function can be passed to another function. So we can have a function to which we can pass another function. So I have a function called as yell, and I am mad at Rahul. So I'm yelling at Rahul. Rahul, kya kar rahe ho? So I'm going to yell at Rahul. So I say YELL, and Rahul did not do the assignment. RAHUL. So I'm yelling at Rahul. Gussa kar Rahul pe. I'm yelling at him. Okay. I'm using emojis. That's also available in Python. You can make use of them at any point of time. I have a method called as greet. This time around, Rahul has completed his assignment. I'm going to greet Rahul, saying GREETING, greeting, and I pass Rahul once again. So last time I was yelling at Rahul, I'm saying, hello Rahul, good evening, because I know he has done the assignment. These are two different functions that we have, yell and greeting. Both of them take a string as a parameter and does something. Yell is yelling and greet is greeting. It does something. I have another function called as call. What can I? This is a very interesting function. It takes a function as a parameter and it takes the name as a second parameter. It returns nothing, and it says message equal to function.text. It gives a call to this particular function which will pass, gets the result, and then print the result. Okay, let's do it. That's a function that I have. I now say call. Which function I'm going to call? I'm going to call a function yell, and the name that I'm going to pass is Pooja. So function में यहाँ yell आ गया और text में यहाँ Pooja आ गया. So here when I say function, it's an indirect call to yell. I'm going to yell at Pooja. Next time I say greet and Pooja. The function name is greet. Text is Pooja. So I'm going to call greet function with Pooja. greeting function with the name Pooja. I get the message, whatever it is returning over here, I'm going to print that message. Let's do it and see. So I'm yelling at Pooja and I'm greeting Pooja. Then I say str.lower Akash and str.capitalize Akash. So I'm calling a predefined method called as lower from the string class, and I'm going to pass Akash, which is an uppercase. So when I say uppercase, it has given you lowercase Akash. When I say capitalize Akash, so I'm saying call this function string.capitalize is a function that I want you to call. And what I'm going to pass it is a name called as Akash is what I'm going to pass to it. Capitalize हो गया, A capital, everything else is small. Okay. So what have we done is we have created a function to which we are passing some methods or user-defined functions as a parameter. So we can pass function as a parameter as well. You understood this? Quick feedback. I'm sharing two different examples with you. The only thing that we haven't seen now is function returning a function. And that's another topic for our discussion. And that's something which I'll take up later when we meet. Tomorrow, when we meet, I'll give an example of writing the code, functional style and imperative style. You could do that operation actually. Take an assignment for today. Define functions, multiply, add, divide, and power. Define function, multiply, add, divide, and power. Which takes two integers as a parameter. Which takes two integers as an argument. Which takes two integers as its argument, as their argument, and performs the necessary operation. That means add will add two integers, multiply will multiply integers, divide will divide two integers, and so on.
Sir, as argument and
आगे क्या बोला मैंने?
And perform necessary operation.
And perform necessary operations. Next. Continue करना है. Create a menu. Create a menu. Create a menu. Asking the user the operation to perform. Create a menu asking the user the operation to be performed. Operation is the arithmetic operation, add, multiply, divide. Okay. And perform the operation on user choice. यानी यूजर ने कहा ऐड तो ऐड करो या चॉइस वन जिसका मेनू में अपने चॉइस वन ऐड दिया है तो अगर मैंने कुछ मेनू ऐसे क्रिएट किया है सपोज what if I have menu something like this suppose accept data multiply addition division power exit ऐसा कोई फंक्शन है मेरा यूजर ने चॉइस 2 दे दिया तो दो नंबर को मल्टीप्लाई करो 3 दे दिया तो ऐड करो 4 दिया तो डिवीजन करो पावर दिया तो and exit कहा तो स्टॉप करो. You will keep on generating such a menu. ऐसा मेनू आप क्रिएट करोगे And depending on the user choice, you will perform that necessary operation. Accept data कहा तो 2 integer accept करोगे, multiply में 2 integer multiply करोगे, addition में add करोगे, division subtraction power, exit कहने पर आप stop करोगे. That's a menu-driven program that you do. So in simple words, I could say, write a menu-driven program to perform basic arithmetic operations, addition, multiplication, division, power, kind of. Write a menu-driven program to perform basic arithmetic operations. So that's your assignment. Let me see how you write it, and I will introduce you to different techniques of writing this code. Same example, by using what you have learned till now, functions or objects. So that thing I'll teach you. But I want to see how you write that particular function, so that I'll show you another way to do the same thing. Okay, so come prepared, do write that particular code and come prepared for the session tomorrow. On that note, we'll stop here today. See you tomorrow. Take care. Love you all. Bye-bye.